Hi, this is Mr. Adams from Midwood High School, and this is a video on naming and writing ethers and organic acids. Ethers are recognized by the fact that they have single bonded oxygen surrounded by carbons on both sides. Okay. In terms of naming them, this is very simple. Okay, you treat the carbons on each side, okay, as branches, and the oxygen gets treated as a tree trunk or parent. Okay, so once you've recognized you have an ether on your hands, the parent name will be simply ether. All right, and then you go from there in terms of naming the carbons on the sides as branches. Okay. Now, also, if you have two of the same group of carbons, same number of carbons on both sides, we'll use the prefix di. Okay, so we'll do this guy at the bottom first, all right? We see that's the ether. We have oxygen, all right, single bonded to carbons on both sides. Now, we have one carbon here, right? Now, the prefix for one is meth, and since we're treating it as a alkyl group, we'll get a YL ending, all right? So we'll say simply methyl, okay? And we have two carbons right here together. That simply would be ethyl. And the parent is the oxygen with the single bonded on both sides. That's our ether, and we're done, all right? So that's very simple. Methyl ethyl ether is the name of this guy. If you call this guy ethyl methyl ether, you'll be correct also. So that's the nice thing about ethers. They're very simple to name. All right. Now this guy right here also recognized single bonded oxygen, okay, with carbons on both sides. But these carbons are the same. We have two methyl groups. So we simply call this guy right here di methyl ether. Okay, and we're done. So there's two examples for ethers, and we're moving on. All right, carboxylic acids, also known as organic acids, okay, are also pretty simple to name, because if you know how to name alkanes, you know how to do these guys easily. A number of guys on table R follow the alkane as the parent, and with mild modifications to the suffix. So let's watch out for that. Always use table R if you're not sure about something. As always, we have to identify the longest number of carbons possible. The organic acid group, okay, must be in that parent. All right, so that's a bit of a typo there. So it must be in the parent. And when we name it, we simply drop the E and add OIC. Now you recognize organic acid groups or carboxylic acid groups by carbonyl, okay, connected to an OH. All right, so when you carbonyl and OH together, you have this COOH, okay, group. That's a carboxylic acid group or organic acid group. That's how you recognize it. All right, so that OH alcohol group with the carbonyl gives us COOH. That's our carboxylic acid. Now let's get in the lower left corner. Let's name this guy. All right, so we have 1, 2, 3, 4, 5 carbons right here. All right, we notice we include the carbon of the acid group, okay? And we always will have the acid group at carbon number 1, always. So we don't have to put the position of the acid group when we give our final name. So that's carbon number 1, 2, 3, 4, 5 carbons. Okay, we write pentane down, but we will drop the E and add OIC, right? So that'll be pentanoic acid, and we're done. All right, so that's how simple that is. Now we have this other guy right here. We have this as our longest continuous chain, including the carbonyl of the acid again. Carbon number 1, 2, 3, 4. So that's going to be butane, right? Okay, but we'll drop the E and add OIC. So that's butanoic acid. But we're not quite done here, because we notice we have a carbon, or one carbon branch hanging on the side, which will be a methyl group. So we say methyl butanoic acid, right? And what carbon number is that methyl group hanging off of? Yes, it's hanging off of carbon number 2. So we simply say 2-methyl butanoic acid. And that's the name of that guy over there. 2-methyl butanoic acid, and you're done. All right, moving on. We have two guys right here. You can pause the video if you want to name them. All right, and draw the structures I mean. And we'll see what we do. Okay, we have ether, right? So when you look on your table R, you see, you know that ethers represent oxygen with some number of carbons on both sides, all right? So on one side, we know there's methyl, so methyl represents 1 carbon. We put our hydrogens in, he's done. But, all right, represents 4, so we put 4 carbons here. 1, 2, 3, 4. You put your hydrogens in. Okay, and you're done. Okay, so that's methyl butyl ether. If you put the butyls on this side and the methyl on this side, it'll be correct also. Okay, so the nice thing about ethers, they're very, very, very simple to draw and to name. This next guy is an acid. It's heptanoic acid, so automatically we know hept stands for 7 carbons, so we'll go 1, 2, 3, 4, 5, 6, 7. The acid group is at the ends always, so we put our acid group in, double bond O, carbonyl, connected to OH, all right? And at carbon number 5, we have an ethyl group. So this, okay, the carbon in our acid group will always be carbon number 1, all right? So that's carbon number 1, okay, 2, 3, 4, 5. So here at carbon number 5, we will put in a ethyl group. So I'll put C right there, connected, and we're done. And all we have to do next is fill our hydrogens in. So we'll fill our hydrogens in. Okay, and as always, we have to be careful when we fill our hydrogens in. We don't put too less or too many, and we're done. We don't have to put any hydrogens here because we have 1, 2, 3, 4 bonds around the carbon. So he's satisfied, he's good. That's how you do it. That's 5-ethyl heptanoic acid and methyl butyl ether. All right, folks. As always, hard work with sacrifice equals success. This is Ethers and Organic Acids. Please study hard. Take care.